Good morning, everyone. I'm very happy to be presenting to you today from Jamaica. I'm from a small island developing state, and I've worked across about 10 countries, but one of which were developing countries. And so it's from this perspective that I'm going to speak to you today about the reality of trying to be sustainable. There are a few takeaway points that I'm going to highlight in this presentation. The first one of which is that the world is still growing. And with that growth, we need an associated increase in the number of buildings. And also, as structural engineers, in order to address sustainability, I believe we need to think more holistically. So considering the context of sustainability, we have a constantly growing global population and associated increase in needs because of that growth in population. At the same time, we have only a finite amount of resources in which to meet these needs. Looking more closely at population growth, we currently have about 7.7 billion people on the planet. There were studies that were released earlier this year that said that they expect the population to peak at around 2064 at 10.3 billion people. So that's an estimated 2.5 billion extra people on the planet in the next 40 years. The table that you see in front of you shows different regions of the world and the current population densities versus the projected population densities towards the end of the century. You'd see that all regions of the world will see an increase in population except for Europe, which is actually going to see a decrease. The major growth in different regions of the world will actually take place in Africa and in Asia. So the white line shows the population in 2010 versus what we expect around 2100. Accompanying this population growth is an increase in demand for building floor area. So the UN Environmental Programme in 2019, their status report on buildings and construction projects that by the year 2050, they expect to see double the amount of buildings on the planet. So can you imagine doubling the volume of existing structures that you see around you today? Now, this is an opportunity for us as structural engineers to do things differently. Because if we build the same way that we've been building previously, looking at the same amount of carbon, then it's highly unsustainable. And associated with this increase in buildings, there'll be a shift towards urban development. So right now, about 52% of the world's population reside in urban areas, and towards the end of the century, over 80% of people would be in urban areas. In this same report, they found that this sector of building and construction accounts for about 40% of global CO2 emissions, and it also accounts for almost 40% of all of the energy consumed annually. Now, this is a key point for us. Because of the pivotal role that we play in this sector, we have the unique opportunity to be the catalyst for positive change towards achieving sustainability once we account for all of these things. And what can we actually do about it? So there are a few things that we should be doing. A lot of the presenters in our conference, they spoke about many of these things, and I'll just highlight a few others. The first is thinking holistically. So we need to step out of the structural engineering box, or at least open the lid. We need to consider other factors and incorporate all of these into our thought processes. First is designing for the future. So this is a meme that I got from a friend of mine earlier in September. And it says, if you're not in the path of a hurricane, one will be assigned to you shortly. And the image below is a satellite image of the Atlantic region from the National Hurricane Center that showed all of the active tropical systems, storms, and hurricanes across the Atlantic at that given point in time. And what we're finding is that possibly because of increasing ocean temperatures, that we may see more and more of this being the norm. So this is the third time in history that we've exceeded the named hurricanes for the Atlantic, and so we're now into Greek letters. And when we have events like these, you also have impact like this. So this photo here is from Dominica after Hurricane Maria in September 2017. Any location, any country that's significantly impacted by a natural disaster looks like this. It results in millions of tons of debris and waste and a huge demand for rebuilding and reconstruction after the event. So this type of failure is something that should not happen. we should design structures so that they don't fail. And I don't mean over designing structures, but it means more careful thought and analysis into what sort of loads the structure would actually be sustaining. So because of climate change, as you get closer to the equator, you'll have an increase in design wind speeds. So account for that in designs and account for that in retrofits of structures. And then also try to adapt your designs towards the actual impact of climate change. And what do I mean by that? So consider, for example, a critical facility like a hospital that's located in an area that's now going to be a potential floodplain for some times of the year due to increased precipitation or rise in sea levels. So let's say you don't utilize the ground floor level for operational space. Use it for parking in normal times. And then consider that you have ramps that you can access the facility from first floor level upwards, and that facility can remain off-grid and functional for a period of 5 to 10 days, for example, so you can continue to provide essential services. That's a type of thinking that we need to adjust to in order to meet sustainability needs. Then the other thing is passive designs. Now, some people also spoke about natural lighting. It's incorporating all of the natural elements we have around us, and many of you may already be using it partially in your designs. I'd like to bring it more to the forefront of your conceptual design process. So think about natural lighting, natural ventilation, the thermal mass of building properties, and how you can reuse, recycle, or harvest rainwater. And by doing that, you're less reliant on man-made products, and you become more sustainable because you're not taking more resources out of the environment. A simple illustration. Say you were to consider the balance between natural lighting and the heating or cooling load of a structure. So scenario one is where you have a room, say a conference room, that has no windows. You can artificially light the space. And all of us already thinking, well, that's not very green because it's very carbon intensive for the operational load. Then you can introduce windows or full height glazing, say on the western face of the building or on the roof, like we saw from Steve's slide. But that then tends to bring a lot of solar radiation on the structure, and then cooling loads become a problem, especially with increasing temperatures. What we can then do is then try to incorporate passive solar shading elements. So you're reducing direct solar radiation onto the structure. You still get the benefit of ambient lighting, and you have a reduced cooling load. So it's a more optimal design. The other aspect that I want to raise is how can we use land space more efficiently? So I did a couple pro and con points about comparing suburban low-rise spreads, so say single or two-story structures for residential development, versus medium-rise, 10 stories or less in an urban development. The suburban spread would utilize considerably more land space. And the Food and Agriculture Organization of the UN, they've made a direct correlation between increasing global population and reducing arable land space. Now, food security is already a problem for many countries, and with this increase in population that we're expecting to see, this problem is going to be exacerbated. So by us as structural engineers influencing our clients to utilize less land, we'd be helping to alleviate this potential problem. The other thing is, from studies of healthy cities, it was found that people who live in urban environments tend to be healthier than people who lived in the suburbs. Why? Because from urban environments, you tend to walk more. You can leave your apartment complex, you can walk to work, you can cycle, you can take public transportation, you can access amenities around you. If you're in the suburbs, you tend to jump into your private vehicle to get to your office or otherwise. So this is another big consideration. And I think one of the other trends that we need to probably switch to is considering the overall embodied carbon in an urban medium-rise development versus, say, suburban or individual houses. Because yes, the single or two-story structure would have less embodied carbon. However, if you were to house more people in an urban development, your infrastructure towards that space is also probably a lot less. So your total embodied carbon for that development, or the embodied carbon per person, would be a lot less than the suburban spread. And then the concept of true sustainability. Now, again, speaking from a developing country perspective, we need to start building simply. As in, we're probably doing that already, but if you're proposing solutions in countries like Africa or the Caribbean where I am, or Latin America, Don't propose solutions where you have bespoke materials and connections that are only going to be used for your project. Consider projects that can be done utilizing local labor and have the transfer of knowledge, so you have the spread of sustainability. You want to be able to replicate your sustainable solutions so that the communities can use it after your project ends. And then also consider ease of maintenance. Now, we tend to have a systemic problem of lack of planned preventative maintenance. And this is where you should use materials that are more durable. You should consider if you do have local capacity to execute maintenance, planned preventive maintenance, and make it as simple as possible. Because the photo that you saw with the damage in Dominica, a lot of that can be attributed to lack of maintenance in many of those buildings. And then the other part is the types of solutions that you propose for sustainability. So the photo that you see here has a green wall on the structure. Green walls are fabulous. They're fabulous in urban environments because they clean the air. They also provide insulation to buildings. But if this building is located in an area where water scarcity would be a problem 6 months out of the year, then it's probably not such a great solution for that project. And then a couple points to just bring it all together is we need to get more informed as structural engineers. So yes, we need to find out about lean designs and embodied designs and reuse of structures and developments in technology. It's all fabulous, but you also need to find out about what's the direct impact of climate change, what's happening in the area of projects that you're working in, what are trends that are outside of just structural engineering that you can incorporate into your designs. You need to broaden your knowledge base. And then you need to also collaborate with others. So speak to other engineers, learn from their examples, collaborate and discuss how you can propose better solutions for your clients, how you can change the status quo, but also discuss with service engineers, architects, contractors, planners, developers, and also specialists in different areas of work. So if you are working on health centers, for example, like what I do a lot of, is there loads of trends and developments in that field of work that often doesn't intersect with our arena, but you can learn from what affects them and what impacts them and incorporate that into your design for an overall more sustainable project. And then use all of this knowledge and experience. Use your critical thinking and your creative mind and influence clients early on in the project. This can actually change the future of sustainability. In order for us to achieve something different, we need to start doing differently.
Thank you, Shalini. Yeah, absolutely brilliant. I mean, a completely different point of view again. Shalini's clearly, not just a structural engineer, but very much you're in the position of having to be a multidisciplinary designer all of the time, and therefore multidisciplinary influencer. And I think that, there's so much we can all take away from that on projects small and large. Don't be afraid to ask the question, even if you have to preempt it by saying, of course, it's not my discipline, but why have you put the windows on this side, for example? And I really like the point about, questioning and understanding where you're working. And for those of us who work internationally, and many of us maybe are based in one country but are working in others, how well do you understand the sustainability drivers in the country where you're working? Are they the same or different to at home? Is denser better or is lower better? How deeply have you thought about it? And I've got to say, if there's one sort of takeaway message for me from those slides, it was to do with the slides on population growth and building growth, and it really hit home for me just then that those of us who live and work in the so-called sort of developed world have very little need for more buildings. Most of the world's growth in population it does not occur in countries like the one where I'm sitting right now, and therefore if we've only got a certain carbon budget around the world, then I think we need to talk internationally about who it is that should be allowed access to really using that, because there's countries around the world where you need housing and you need education and you need more hospitals, and we need to make sure that those countries get prioritised. So thank you, Shalini. Real whirlwind tour around the world there for us.
Yeah, I mean, thank you to everyone who's sort of spoken already today. One of the delights of going slightly later on is, I think, as you listen to all the previous speakers, you think, oh, that was something I was going to discuss later. So apologies if there is inevitably a level of repetition. One thing I will say, though, that in contrast to some of the talks we've heard earlier today, this session is going to involve perhaps less of this type of thing and instead we're going to talk more about this, which is just really about how you interact with people and how you can use your, I suppose, your skills of persuasion to really influence the brief and the overall sustainability goals of the project. So why does this matter? This is a diagram that probably a number of you have seen already in various incarnations, but essentially highlighting how the potential for carbon reduction of a project reduces over time as proposals become more fixed. Now, at the left, we've got the big ticket items. Do we need to build anything at all? Is this the right site? What is the optimal position for this building? Can we reuse existing structures? And of course, any of those have an enormous implication for the sustainability of the project. And, that's what we should be targeting in the first instance. But if you're not in a position to influence those decisions, or perhaps you've picked up the project further through the process, it's often easy to think that, you can't really have much of a positive impact on the overall sustainability. But at the end of the day, there's still a huge amount of room under the right-hand side of that curve, and it's still there even as the project nears completion. And we as professional engineers, we've got a duty to do everything we can at every stage to make the project as sustainable as it can be. And this is something actually Will said when I was speaking to him the other day, which I think is really important, because even if you feel like all the wrong decisions have been made right at the start, demolishing a perfectly serviceable building or a desire or commitment for using less sustainable materials, what can you do to improve that? So using those examples, could you knock down the superstructure but perhaps reuse the foundations? How can you use as little of those less sustainable materials as is as possible? So some of the examples and ideas we touched upon perhaps might seem a bit basic or obvious, but I think until they become routine on every project we do, it's still worth highlighting them. So I think this is an important point to ask the question, what is a brief? That might sound a little bit ridiculous. I mean, of course, we all know what a brief is, but do we? The official brief from the client can potentially be quite loose, fluid, something that's very malleable. Often it's fleshed out by others who've had involvement before us, potentially without fully understanding the negative consequences of some of the sort of the ways they've changed it or conditions they've added into it. And in some cases, we'll undoubtedly be doing the same. So it's really important, I think, to distinguish between these two things. Brief versus brief. It's subtle but important. Because every step of design and construction process involves effectively a number of briefing examples as highlighted here. And I should apologize. As a consulting engineer myself, I often sort of draw things from that perspective. So apologies to anyone who's on the contracting side of things that's listening. But for example, you might receive a brief from the client, an architect, a project manager. You might brief your own internal team. You might even brief the external team. You brief sub-consultants, the contractor with your issued construction information. Every single time you communicate with someone, there is a brief involved. And as engineers, we often see ourselves as the problem solvers. Our immediate response to these requirements could be how, when really it should be why. And when we actually start to ask why, this diagram gains a load more arrows, a lot of interaction as we challenge others on whether something is really necessary. Why does that building need to be a 20-story tower? Why do we need a 3-story basement? Why is there a drive to use that particular material? And it's right that others ask the same of us. Why is that slab so thick? Do we really need such deep foundations? And this is the part where it becomes really important to have that rapport and know and understand the people you're working with, because it makes asking those type of questions a lot easier. I think you need to understand who is driving certain requirements and why. Are they vetoing perhaps what you perceive to be a more sustainable option because of a bad experience in the past? And what are their motivators and how can you use these to your advantage? If your client doesn't particularly care about the sustainability credentials of the options on the table, Mike said earlier, hopefully this will become less of an issue as clients sort of realise, I suppose, the moral importance of this. Are there other benefits? Does reusing the building save on cost or program? Can we get additional BREEAM points or other sustainable certification? Is there a first that we can achieve? The first building to have some sort of marker that will make the building more attractive to tenants or occupiers. Shalini talked a lot about holistic design, which is fundamentally important. You really need to break outside of your own silo. I think often people can be quite hesitant to question other disciplines, assuming that, if there was a viable alternative, then someone else with perhaps more specialist experience would, of course, thought about it already. But I think you can use this sort of relative ignorance to your advantage. It allows you to ask what might appear to be the stupid question without fear of, I suppose, being exposed. And sometimes that stupid question is the very one which challenges people to really consider alternative, more sustainable or efficient solutions. Just a quick example here. So I was on a recent project where we had a site with exceptionally hard ground. It was a sloping site. It was frankly the worst site in the world. But overall, we sort of came up with a proposal for it. But the end section of the building meant that the lower levels stepped. And in an early design team meeting, the MEP team, the architect were debating how to arrange the building plant. And the default position was on the roof. At this point, it would have been easy for us to switch off from the discussion. Let's be honest, we're all guilty with modern technology of sort of checking an email or two during a quiet period in a meeting. But everyone seemed to be overlooking the fact that the natural slope of the site gave us this sort of void space underneath the building. It had insufficient head height to be incorporated into the main floor plate, but perfectly adequate for some of the heavier plant items, which meant that we could then just leave the AHUs on the roof. By moving the heavy plant to the base of the building, it meant we could reduce the roof slab thickness using smaller supporting columns and even the extent of the rooftop plant enclosure. So I think just don't assume that because it's not your area that there's nothing to contribute. Similarly, try and unpick what's driving the decisions of others. Speak their language and show that you understand what they're trying to achieve and that you're jointly working towards that. Everyone wants their perfect solution, but sometimes one party writing that in stone comes at significant cost for all of the other disciplines as they try and work around it. If we can really get to true collaborative design and compromise, we might not get exactly what we individually want, but instead everyone gets close. 90% of the optimal architectural layout, 90% sustainable structure, 90% of the most energy efficient building services, and so on. It doesn't really need to be at a global level either. And this, I think, is similar to an example that I think Maggie referenced. I, inherited a project where the architectural team had requested a flat slab, exposed concrete soffit, but it wasn't really the optimal, column arrangement for a flat slab. And digging a little deeper, it turned out the reason why they wanted this was they wanted the slimmest structural zone to create the feeling of height in what was quite a restricted space. But all the lighting and acoustic treatment would then need to sit below the slab and encroach on the space below. And whilst, yes, the 300mm flat slab did give them the shallowest structural zone, it didn't seem to really give anyone what they actually needed. So we worked up a rid slab proposal, and it wasn't the shallowest, but it allowed the lighting and acoustic treatment to be recessed into the coffers. It even helped with the air extract positioning. And more importantly, it allowed for a 45% reduction in concrete volume across the entire floor. And so, like Maggie's example, it's a simple change, but a big win, and just came from challenging that requirement that we'd been given by the architects. And when you're assessing solutions, at the early stage of a project, and you're looking at various options, don't just respond to the constraints of the brief. Give positive suggestions as to how it could be tweaked or improved to make more sustainable options work. And don't be afraid to think radically. Could you move something to a sort of large open space that needs a heavy transfer structure from the bottom of the building up to the top where you can avoid having that transfer structure altogether, even tweaking the column grid. And I think the important thing is confidence. Often we as engineers will sort of wait to go away, fully check something before you raise it with the rest of the design team. But don't. Share those ideas and gut instincts, because the longer you wait, the harder it will be to change other people's minds. And you might not be able to influence this every single time, but let's be honest, this is hugely important, and so even a low success rate is better than none. And use tools and techniques to communicate the scale of the benefits. Comparisons with volume, weight, car trips to the moon and back. I quite like the idea of a lifetime sort of carbon use to compare it. I had a project once where a fantastic project, massive cultural centre, famous architect. The design team were really confused as to why, we as engineers, we were talking about the key sort of building components, but we were also really keen to discuss the sort of man-made hill, which you can see on the right-hand side. Doesn't really look much on a section, but then we showed them this, and all of a sudden they immediately understood that this hill was a significant engineering undertaking in its own right. Now, whilst this sketch was to illustrate some of the other structural challenges, it also highlighted why we were keen to find and explore more sustainable solutions for its construction. So we focused a lot more on the creative design issues so far, but on every single project, there are inevitably quantitative requirements woven into the brief. And for us as structural engineers, often the most significant of these is live loading. And apologies, this is where you probably are going to get a little bit of repetition. So it's the images from John's report on live loading. So the left-hand image, typical meeting room, loading equates to just over half a kPa, and yet we as engineers are often asked to design office spaces for 2.5, 3, even 5 kPa. To achieve that 3 kPa, you need to put 29 people in just under 7 square meters, which is cozy by any standards, let alone in the kind of current socially distanced world. And 5 kPa is impossible without really getting to levels of contact that I don't think you'd see outside a rush hour tube train. And I think also with load requirements, particularly for speculative offices, you can often get into a game of top trumps where, the higher the number, the better. But even sort of spaces like libraries only have loading requirement of 4 kPa. So highlight to a client and a design team what those loads really mean. What are the potential environmental and cost savings if you could actually pare them back? Can you use first principles to more accurately define these loadings? It's something as we've already heard today. Sticking with libraries, there's often still room for maneuver, even when you're dealing with, the limitations of the code. When is a library not a library, I suppose? It might be a library in name, but especially in modern libraries now, a large proportion of them is really more like a reading room with limited, if any, book storage at all. And I think by really interrogating, what these spaces are, for example, something like this, if you can formally designate it for that reduced loading, in this case, that represents a 40% reduction in the live loading. And if there is a real need to incorporate higher loadings, then treat the lower general case as your baseline. Work out where the best place to put these higher load capacities is. Can you achieve that necessary area or close to it using areas of the floor plate that have already got some sort of latent structural capacity? If you think about a concrete flat slab, the desire and practicality to have a uniform thickness means that some areas might be able to achieve this with only a marginal increase in reinforcement and therefore embodied carbon. So shorter spans or internal spans adjacent to the cores. Try and let the structure guide the design and inform, the layout that others are working around. Natasha I think it was Natasha who spoke about this earlier. We talk about flexibility, and for a long time we've been advocating the need for sort of a long life, loose fit design, building in that flexibility at the outset and avoiding the frustrations that anyone who's ever tried to repurpose some of the hyper efficient buildings constructed in the 70s will be able to appreciate. But we've got to use a level of intelligence, and I appreciate it's a slightly daft image to include in a structural climate emergency presentation, but someone driving their shed across a beach at 100 miles an hour does perhaps highlight the need for being able to reasonably understand what is a level of flexibility that can be expected. None of us have a crystal ball, so rather than a brief requirement to design for a myriad of potential future requirements, all of which will have an inevitable increase in the embodied carbon, why not design on the assumption that the building may need modifications in the future? How could the slabs be strengthened in the future? Can we infill perhaps void areas to provide additional floor plate? And you might arrive at a hybrid solution, perhaps with columns and substructure having inbuilt additional capacity, but a clearly communicated strategy for future flexibility. And the importance of this is so fundamental, because it's no use having a great idea and a sort of a cunning plan if you don't tell anyone about it, especially, if it's 20, 30 years down the line that they actually need to implement it. And don't forget the specs. Hugely significant documents, often sent out with the same standard clauses. This is you briefing a contractor and tying them into quite specific requirements. And as we heard earlier, this can help you reinforce the brief and ensure that any commitments with regards to lean design, product specification, etc., are carried through. But even the basic clauses that you think of as just being routine, do you actually understand what they mean, what you're asking for, and potentially what implications they have for the sustainability of the project? And finally, I've spent a lot of time talking about the ways in which we need to challenge the brief from others, and that's been focused really on paring back what we do. But there's a huge opportunity with the brief to positively influence it. Can you commit the client and the project team into, adding sustainable goals or upgrading those which are already there? In England, the planners often include a requirement to work towards a certain BREEAM level, and some see this as a bit of a get-out clause, allowing us to achieve the level below what's mentioned. But what if we committed to actually achieving it? What about committing to utilising local materials or labour? And I suppose one project I feel that really embodies this, if you excuse the pun, is one worked on by some of my colleagues here at BDP, which is the Enterprise Centre at the University of East Anglia. But this sort of predates me joining the practice, but the client was keen to use local resources, and indeed some of the funding was dependent on this. But rather than burying it in the spec, this became the key driver for the design. So in this case, locally sourced timber and using local out-of-season labour for the thatched facade. And engaging with local suppliers, it became evident that the smaller scale UK industry would find it really difficult to compete economically with some of the European timber frame companies. So we kept it simple and designed a structure which made the UK suppliers much more competitive. This wasn't about, our own engineering indulgences, but rather allowing the local materials and workforce to shine. Now, in the end, a large proportion of the timber used was sourced from the local area, which not only ensured that the project had broader societal sort of sustainable goals, but also that it was able to achieve a huge reduction in the embodied carbon. So we used nearly 80% renewable materials, and the final numbers were sort of 168 kilos of CO2 per metre squared, which for a building this kind is fantastic. So I suppose in summary, it's really just to highlight that influencing the brief isn't limited to concept stage. Challenging the brief you're given and what you communicate to others is really important all the way through. Build a rapport and step outside your own silo. Understand what's motivating the others in the design team and build your case to change their minds. Small changes can have big gains. Be proactive in highlighting them. And a quantitative requirements as fixed as they seem. Focus on adaptability rather than flexibility, and really don't forget the specs. And finally, positively influence that brief. Get sustainability written into it and committed to. Thanks.
Fantastic. Thank you, Victoria. That's a really good summary of it's a to-do list for tomorrow, if I've ever seen one, or today, in fact, as soon as we've finished with the conference, but not before. Thank you both, Shalini and Victoria. Really, really wide breadth of thoughts there. And I think, you both talk about the sort of confidence to share ideas and opinions. If you think they're outside of the role of a typical structural engineer, that's still worth saying. Victoria, you talked about, even if you're not 100% confident it's going to work, it's probably still worth sharing to at least get design ideas on the table. I think there's, it's all harks back to what Mike Cook said right at the start of the conference about this being a global problem and needing global solutions and needing people to really work together. And of course, we can't do that if we're not going to share ideas. And I think, what I took away from what you were just saying, Victoria, about, all of these individual design decisions and questioning them and trying to work out how they could be better or be better for the planet. This is all practice for the time where later on in someone's career, you might have the opportunity to make a really big carbon saving. And of course, when that opportunity presents itself and you have the opportunity to try and convince your clients on this new job that, of course, they could reuse an entire basement or, just extend the building, we need to be well versed in communicating those ideas. And so I think, if nothing else, questioning what type of floor plan you have and columns, it's all practice for the bigger decisions further down the line as well. Really good, thanks. We've had a couple of questions through, particularly for Shalini. We've had a few people sort of mention, they're really happy to hear people talking about, perspective from a place where resilience is priority. And I think the first question that I thought was quite interesting to maybe ask for Shalini is, how do you think we can ensure that resilience is put at the heart of the brief for buildings where when you're working in an area where that's a priority? Is there something to do with standards, codes, financial incentives, or something bigger than engineering, or is this about communication with the client? What do you think?
Right. Really good question, Will. to be honest, we do have codes and standards, and here in the Caribbean, for example, and probably in a lot of developing countries, you sometimes don't have up-to-date building codes, so they would tend to use the American standards or British standards or European codes, depending on which part of the world you're living in. And sometimes those codes and standards aren't fully adapted to your region. So oftentimes, if you do have local engineers who are using it and they don't fully understand what their loads are and the risk of the location of their structures versus the types of codes that they're using, then oftentimes you may find that they're under designing for um, what's actually going to impact that structure. So some of the failure that you tend to see, like the uh, earthquake in Haiti, for example, where 220,000 people died and, basically all of their structures in Port-au-Prince collapsed. It's because they don't design for earthquakes. And so resilience, I think, starts with one, when you get into a country, educating locals in terms of what are their actual hazards and how are they properly incorporating that into designs. Um, because it's quite shocking sometimes to know that long time practicing engineers don't design for earthquakes in countries that do have earthquakes. And that's just one example. Another thing is when we do see types of failures like the one I showed, then clients tend to wake up because they don't want to have that kind of damage that the neighboring countries experienced. And so they bring consultants in to check their resilience of their structure and then try to strengthen and do things. But I think some simple concepts in geometry is often missing and simple structural forms that work. So for example, shell roofs. Shell roofs are great for one, the embodied carbon is a lot less because you can have a 75 millimeter roof that's spanning very large distances without any supports in the middle. So it's a lot less embodied carbon compared with a structural steel roof or even timber, because timber often needs to be brought in from other countries. And then the contemporary sort of flat slab roofs. And so, but a lot of people don't practice it. I think sometimes they're a little bit afraid of it because the geometry seems complex, and then sometimes you do get a bit of pushback from contractors, for example, because they think that it's too complicated. So oftentimes, if you're dealing with more, this is not an insult, more simple-minded builders, they would tend to just go with whatever you've given to them, and then it turns out to be okay. So there are loads of different aspects to look at, but yeah.
Yeah, I think that I like the shell roofs. So we've had a comment as well, which I guess is maybe a question for both of you, but I'd be interested. Maybe we start with Victoria. So somebody asked a bit earlier today about, do you have experience of trying to convince contractors or maybe very contractor-minded clients to allow you to follow up with these more efficient floor typologies, waffle slabs, bolts, arches? Obviously, Victoria, you mentioned ribbed before. But have you had experience of trying to persuade others to let you go with what's seen as a more complicated structural solution because of the benefits it brings sustainability? And if so, how did they go?
Absolutely, yeah. I mean, there was actually one that's very relevant to that specific question. Talking about waffle slabs. We had a project. It was in fact, it was the one I referenced earlier with the big hill, and it had it was in a seismic zone anyway, and we had a green roof across the entirety of the building. So we were doing everything that we could to minimize the volume of concrete in the roof. Not only, and this was an area where concrete was the sort of the most readily available construction material. So we were trying to find ways to actually give a sort of this flat soffit, minimize the weight of concrete. And so we actually developed a full kind of construction sequence for how and this was a really, really sort of detailed level of how they could construct. It was basically a voided slab, so sort of the waffle slab with the bottom surface added on. And again, we didn't want to go down the route of having to use sort of, polystyrene formers or anything. So we actually developed a sequence that meant they could actually use a sort of a reusable timber formwork to do that. And I think it just comes down, it's that communication. And because I think a lot of the time people will shy away from things thinking that they're, it's too complicated. And it's the risk. That's what people don't like. So I think if you can actually demonstrate that it's achievable and that it can be, cost effective, and it will also have all these other benefits. I think there's, a huge opportunity there. So it all comes down to, I think sometimes, how can you de-risk it for them? How can we kind of communicate that? And that is your kind of key tool in persuading them.
Oh, fantastic, yeah, and I mean that comes back to so much of what both of you've just been saying. This is, at the end of the day, this is about speaking somebody else's language, isn't it? So, where you might have a client who doesn't outwardly have any sustainability ambitions. I know Margaret earlier spoke about that sort of scenario where actually, if you dig into it, maybe they do. But even if they maybe don't, we can talk. We can still frame efficient designs in terms of risk and cost and long-term resilience and all those sorts of things. So it's about trying to break outside of our own comfort zone and speaking somebody else's language, not just our own.